So now in this video we have a touch activated 555 timer flip-flop right there. So now the diagram that I'm using here is an old one. I had a issue with the ink not coming out black for some reason, but in any case I'm using an NE555 timer. There's other variations. My older diagrams I used to put more detail on there, so I always consult the data sheet for the particular one you're using. You can also just test it out. Its properties. But there's the pin names right there, and here's the numbering system. You got the indents on top. Sometimes there's one, sometimes there's two. Top left is 1, work your way down, keeps going up, and then when you get to the bottom you jump across and you work your way up. There's longer integrated circuits. It's the same system. Now we have the circuit here. So we have pin number 2, the trigger pin. So it's waiting for a low input. 1 million ohm resistor. We need a high value resistor because my body can't provide much current. So 1 million ohms of resistance to the 5 volts. That keeps it off until I press it. So there's alternating current around me in the house. They're bombarding me with electromagnetic waves, and so I'm actually building up and down a voltage. It's going up and down. When it drops down to less than 1/3 of the supply voltage, then the output goes high. So it's not quite 5 volts, but relatively close. You lose maybe like a volt. And then we got pin 6. So pin 6 is waiting for more than 2/3 of the supply voltage. 1 million ohm resistor is pulling it down to 0 volts. Again, we got to use high value resistors because my body doesn't produce much current. And if I touch it, then it goes up above 2/3 supply voltage, just briefly, but that's all it takes. And then the output goes low because this is active low. The trigger pin doesn't do anything until it gets a low input. Pin 6 is active high, doesn't do anything until it gets a high input. So if you don't touch anything, the resistors are preventing them from doing anything. The output will just stay in whatever state it is until you press the one that will switch it. And here is a closer look at the circuit. So pin number 8 to the positive supply, pin number 1 to the negative supply, and I just falsely triggered it. Looks like we can use the screwdriver instead of pressing it if we want to. And pin number 4 is to the positive supply. That's preventing it from doing anything. It is active low like pin 2, and we don't want it to do anything in the circuit, so we make sure it doesn't. So we got our pull-up resistor. 1 million ohms again, because we can't produce much current. If you use too low of a value resistor, it will pull it to that supply rail that helps hold it off. Hopefully that makes sense. So to get it back low, we got to touch that one. Get it back high, we got to touch that one right there. And so you can see here when the blue LED, there we go, is lit up, we got positive, working our way through here. 1000 ohm resistor, higher value because blue LEDs are brighter. And then it goes to ground right there, which it does pretty well. Now, when we have, there we go, the red LED lit up, that means the output is high. We can tell that because we got positive coming this way to the long lead the anode, short lead the cathode. Always put it in the right way. 220 ohm resistor, again, lower value resistor because blue LEDs just aren't as bright as, red LEDs just aren't as bright as blue. There you can see, even though it's got a lot more current, it's looks like it's still a bit dimmer.